Hi there, my name is Brian. Thank you for joining me. If you like what I do, please remember to like and subscribe. Today, we're going to talk about drive speed tests. There are two types of speed tests to consider, sequential and random. Sequential speed tests are helpful for testing a drive that is copying a large file like a 1 gigabyte movie. The drive uses sequential speed. However, when you boot an operating system, install software, browse the web, or run applications, the drive handles thousands of tiny randomly scattered files. This is where random tests are helpful. In this tutorial, I am going to show you how to use an application called FIO to test a drive's random speed for read and write. For this example, I will be using an NVMe drive that my operating system runs on, but you can do this on any hard drive or SSD, even a flash drive. FIO, which I think stands for Flexible I/O Tester, is a free and open source application. It operates under the GPL 2.0 license. You can check it out on GitHub, which I'll link in the description. Installation, of course, depends on your Linux distribution. Here I'm using Debian 13 with the Cinnamon desktop environment. First, I'll open the terminal. And then for Debian, to install it, we will just run sudo apt install FIO, F-I-O. I already have it installed, but you can go ahead and install it. I'll put my password in. And then once it's completed, running it is super easy. All you do is type in FIO. Now, if you just type FIO, you're going to get a help output that explains the different options to use. Now, with FIO, you can edit a lot of options. For instance, this is what I do. First, I'll clear my screen. Let's make it a little bigger. And we'll start with sudo, of course, and FIO. This tells us to run, or it tells the system to run FIO with super user privileges, which is necessary for some disk I/O mechanisms. Next, we would do a space and then a double flag, and then name equals rand underscore 4K underscore test. Now, the reason I did that is that it assigns a name to this test that appears at the output, which makes it easy to identify. Next, I will put in the file name flag equals. And here we tell it, we specify the file location where the test operations will be performed. This ensures the test will be run on the mounted file system, whichever you're going to run it on. I want to run it on my main operating system's drive, which is /, but it's bad practice to write directly into root, which that's what / is. So I'm going to go home and then my username, and then I'm going to write it right there. I'm just going to call it FIO test file, and then we're going to do space, and we're going to add another flag. This flag, which is --IO engine equals, and then you specify the IO engine, which is LIBAIO. This specifies that we want the LIBAIO engine to run, which is the Linux asynchronous IO, which allows the test to submit multiple requests simultaneously, which accurately simulates modern high-performance IO operations. We want the test to be as useful as possible. That's why we add that in there. Next, we're going to add another flag, so --RW equals RANDRW. This specifies the read-write pattern should be random read-write. So the RW here means read-write pattern, and then this is rand, as in random, and then RW again for read-write. Next, we'll do --BS equals 4K. This specifies that the block size of the files should be in 4 kilobyte chunks. This is the standard block size for most file systems and operating systems. It makes it the most crucial metric for small file performance. Next flag would be --size equals, and this is how large you want to make the test. I'm just going to make this one 100 megabytes, but you can make yours much larger if you'd like. And then we're going to do another space, --. Next one is num jobs equals 4. This specifies that we're putting 4 parallel jobs, which are threads / processors, or processes, each running the full benchmark simultaneously. This helps saturate the drive's I/O capabilities. Next, we'll do another flag, --IO depth equals 16. This specifies the I/O depth, which is the number of I/O operations that can be pending simultaneously for each of the 4 jobs to 16. So we have 4 jobs running at a depth of 16 equals 64. 4 times 16 is 64. This is a high Q depth designed to stress test the drive's controller. Next, we'll put in that it's a time-based job. And what this does, it specifies that the test stops once the runtime has been reached, ignoring the size parameter once the initial file is created. That way you're just not running tests all day long if you're running a large file size. Of course, this is optional. And then finally, we're going to do --runtime equals 30. That specifies the duration of the test run in seconds after the initiation, or I'm sorry, the initialization. So we'll go ahead and run this. Feel free to play with this to get to put in different variables. This is just what I like to run. So I'm going to hit enter. So already we see an output. This is just acknowledging that it understands what we put in. Now we're going to wait for it to run. This should be pretty quick. This is not a very large test. And then it throws out a lot of information. There is a lot of good information here, especially if you're trying to narrow down certain specifications on a drive. But the one that we mostly care about most of the time is down here at the bottom. So drive or disk stats, read write. So NVMe 1N1, that's the name of my drive. If it was an SD or a hard drive, it'd be SDA or SDB, etc. So the results here, it read at 615 megabits per second and wrote at 614 megabits per second. So that's really fast. I'm very happy with that. There's also up here you can see latency, which is the amount of time it takes for the drive to start and complete a single request. It's typically measured in milliseconds. And then you just want to consider the latency for a very fast drive. That number is going to be low. Low is good. So in conclusion, that is FiOS. So you now know how to use FiOS to go beyond simple sequential benchmarks and perform a realistic 4K random read and write speed test on your drive. Remember, the key takeaway is that sequential speeds might tell you how fast you can copy a single large file, but random IOPS and low latency are the real indicators of how responsive your operating system and applications will feel day to day. By adjusting the options we discussed, like I/O depth, number of jobs, and BS, you can simulate different workloads and thoroughly stress test your storage. All right, so I hope this tutorial was helpful. If you learned something new today, please hit that like button and consider subscribing for more Linux tips and hardware guides. Let me know in the comments below what IOPS did your drive achieve. I'd love to compare notes. Also, please let me know if you would like me to cover anything next. Thank you again for watching, and I'll see you in the next video.